All right. Lesson 28, complex fractions, rationalizing the denominator. All right. When it comes to a complex fraction, what that phrase means is we're talking a fraction over a fraction. Okay? So two fractions with a division line between the two. So kind of like 3/4 divided by 1/8. So whenever I talk about complex fractions, that's what we're talking about. Now that one's not so bad. Later on you'll be doing things like that.
Oh gosh.
So 3 over x, and you've got, you're dividing 2/5 by 3/6 first, and then dividing 3x divided by that, and getting into some. But you know, it's not really hard. It's doing the same thing. You just do the same thing 2, 3, 4 times to get your answer. All right. There's a couple ways that the book explains, as far as, or other books explain, how to divide those out. The easiest way to do that is, anybody have any ideas?
Do you make the denominators the same?
You could. That would be a very, very long, drawn-out process, but it works.
You could switch it and multiply it by both.
Yeah. Invert and multiply. So you take the bottom fraction, turn it upside down, bring it on top, multiply, and you're done.
Okay, that was
A lot easier.
The end.
So,
28.
that's it.
Really?
No.
Sweet, let's
Well,
do it.
it's the same idea, but we're going to get into some that look a little bit trickier. In fact, let's just take out numbers completely.
Sure. Why not?
I mean, it's just math. Why would you use numbers?
Yeah.
So, complex fraction, we follow the same procedure that we just went over. We're going to take this, turn it upside down, multiply, and get
Parentheses. Yeah, I remember that.
okay.
You don't.
Boom, can we distribute?
You could distribute, but before I distribute, and this is a good point, Elias, that's a good point, but before I distribute, I want to write it without it being distributed. Now, some of you would try doing this all at once. You'd put the A and B together, and you distribute this right away, and then write it distributed. But if you write it this way, with the A, B on top, with showing that you're going to distribute, you find something very, very important here. Yes, you can cross out the B's. If you would have distributed, you might not even have seen that. But this way, a lot easier to find that.
So your answer is just A and then over X plus Y.
Yeah. Okay, let's do another one with just letters.
Yep.
A over A plus B, all over C over A plus B. Go ahead and try that one. Okay, one thing that you can see on this one is your denominators are the same. If your denominators are the same, you can just cross them out. Okay? Actually, what we're doing is we're canceling, because what we're going to get is we're going to get A over A plus B, and when you invert the A plus B, your other denominator goes on top, you can cancel. Notice I didn't cancel just the A's, I didn't cancel the B's. You have to cancel the entire length
Whoa.
of A plus B.
There you go, there
Okay.
we go. Can you do the same thing if the numerators are the same?
If the numerators are the same, let's do C over A plus B all over C over B. We multiply by its inverse, cancel.
Could you cancel the? No, you couldn't.
No, it ties it.
Yeah. So if you're, and guys, that is one thing. If you can remember that that plus and minus sign ties both all the numbers on either side, that will save you a lot of grief in the future. so many times people are canceling that. You remember that and life will be good, or at least better. All right, so I wonder how I get that down to the bottom of the screen now.
Right here.
Yeah.
Do I? Is that what
Little
I,
four thing, four place arrow.
how do I grab it?
Double click maybe?
Wait, just tap the red line.
All right, let's pause. Thanks, guys. So if your denominators are the same, or if your numerators are the same, you can cancel without having to do any division or anything.
And that's the lesson.
Okay. So the next part of this is rationalizing the denominator. Again, stuff that you've done. Rationalizing the denominator means if we have a radical in the denominator, it's not necessarily wrong to have the rational expression, the square root in the denominator, but it's basically like saying you're not reducing it to its lowest term. All right, so one of the key things that you do in algebra that you didn't necessarily learn that that's what you're doing, you just do it, is if you want to get rid of something in the denominator, you multiply the top and bottom by that number, and usually you get some help there in figuring it out. So actually what we're doing, what is the square root of 7 over 7?
1.
What's that? Yeah, any number, anything over itself is 1. Well, by multiplying something by 1, you don't change the value of it at all. So you can do it, you can change what it looks like, but you're not changing the value.
So it's 4 times the square root of
So it's 4 times the square root of 7. What's the square root of 7 times the square root of 7?
49.
Square root of 49. What's the square root of 49?
7.
7. So all that does is takes the 7 out of the radical
That's
sign.
fantastic.
Okay?
Oh, yeah.
So you don't have to put the square root of 49. Just take one of the square root sign off the bottom and you're done. Sometimes, most of the time, you'll get things like this though.
Dang.
Okay? What are we trying to get rid of?
The
Bottom.
bottom. The radical sign.
Just the radical sign, yeah. I mean, I don't mind that 2 being there. I don't want the radical sign to be. I don't want the radical sign to be in the answer.
Actually, quite.
So since all I'm trying to do is get rid of the radical sign, that's all I'm going to multiply by. Leave the 2 alone. 3 square root of 5 over what? Square root of 5 times square root of 5 is just 5 times 2 is 10. Okay? And then a lot of times you'll be able to look at these here and cancel. In this case you can't, but in a lot of cases you'll be able to cancel. So, try this one. 2 over 3. Let's do square root of 12. So, try that one. And come back when you're done. So, what did you do here?
Times everything
Magic hat.
root is root.
Well,
And then
it's all down to
What I
4,
just
3, square
Okay?
then you
2
can,
square root of 12 over 36.
and you can take the 12 and put it over.
wait, no, then you have
Here.
square root of 12 over 18, right?
Square root of 12 over 18. Right? Are we done?
No.
I would
Okay,
read.
why aren't we done, Tim?
I was just, we need to reduce the 12.
Yes, we can reduce the 12. What 2 numbers multiplied together give you 12 that you can take the square root of one of them?
4 and 3.
I don't care.
Square root of 4 is what?
2.
Yeah, man!
Okay?
So that's what I was saying.
Reduce.
Reduce.
That's why I said 2 outside of the
Now we're done. A lot of that stuff you can avoid because, like, when you get going, you can just look at the square root of 12 and know, oh, it's 2 times the square root of 3. Or square root of 18, what is that? Can you figure that in your head? 3 square root of 2. Yeah. So a lot of these square roots you'll be able to start getting memorized and be able to do those. Okay, that's the lesson. So we're done with that.